take a look at some different trig substitutions that are necessary, or you could say helpful, to computing integrals. So let's start with the following. Let us start with the integral of sine cubed x dx. Okay, so how do we go about doing this? Now, if you tried something like a u substitution, right? You could try what, like u equals sine x, put in a different color. So if we try like u equals sine x, then du is cosine x dx, and we're sort of stuck because it just doesn't work. So it's actually a helpful idea though, which is, can I maybe get a cosine out of here? And so the strategy would be as follows. What you can do is you can split this into sine squared x sine x dx. And the idea here is this du, the sine x dx can be a du if we can put sine squared in terms of cosine x. And of course we can do that using our Pythagorean identity, so this becomes 1 minus cosine squared x dx, 1 minus cosine squared x, and with the sine x dx. And this is now what we want. Why is it what we want? Because now if we just multiply it through, you can see you end up with the sine of x, that one is straightforward, and then we get minus cosine squared x sine x. And that is what we are looking for, because now we can do a u substitution. U equals cosine x, then du equals, you go ahead and write it out. Keep our sign straight. So if we go here, we could say u equals cosine x, and then du is equal to derivative of cosine is negative sine x dx. Okay, and you can see that's going to be nice. And the idea here is you can split the integral into two. The dx obviously goes to both. And integral of sine x dx is just derivative of cosine, right, is sine but negative. So negative cosine x. And then for this one, right, it's going to be then it's going to be a plus because, the signs cancel out. It's going to be u squared, so it'd be u cubed over 3, and u is cosine of x. So it's cosine cubed x over 3. And I forget in the videos, my apologies, many times, so you must remember to put your plus c. Okay, and this general strategy will work for sort of any really odd function. Odd trig function. Okay, what if we have an even one? How do we deal with that? Okay, so what's an example of a similar even trig function? Well, we have, let's go with the sine fourth of x dx. Now, similar sort of challenges and ideas, but it is a little different. So what you can do here is you actually, I think what you want to do is split it up into two even functions. And so, well, I mean, we just did this, but let's just try it. So, okay, so we do sine squared x dx. Sorry, the dx comes after, and sine squared x. And the Pythagorean substitution is nice, but there is in effect another one. There's another formula that's really helpful for us to use here. And what that formula is that the sine squared of x is equal to the following. 1/2 1 minus cosine 2x. And so what you end up with is basically two of these, okay? And this is good. Okay. Move the dx in there. Okay. So what we can do is we can pull out the 1/4, and now we have these two terms, and we can in effect sort of multiply them together, multiply them out, right? And what do we get? We get 1 minus 2 cosine 2x plus cosine squared 2x, all dx. And then you can do it again. So we still have the 1/4, we still have the 1 minus 2 cosine 2x, and then the cosine squared 2x. The substitution is 1/2, and this is 1 plus, see this one's minus, and this is 1 plus cosine 2x, but you gotta double what's in there. So cosine 4x. And now we can integrate each individual piece, right? So we'll leave the 1/4 there. Okay, so that's just x, right? So what's this one? This one looks like just minus sine 2x, because if you take the derivative, it's cosine 2x with the chain rule times 2, okay? Now this we've got a 1/2 by itself, and so that's just 1/2 of x. And then we've got this cosine 4x over 2, and so that's going to be something like the sine of 4x. And then, you can always do these. You can write out sine of 4x, leave a little space. You say, okay, well, what's the derivative? Derivative would be cosine 4x times 4. Wait a minute, I've got times 1/2. And so how do I go from it should be a 4 there. And how do I get it to a half? Well, if you divide it by 8, right? Because you divide it by 8, now you do the times 4, and that goes down to 1/2. Okay, and certainly you can add the like terms. Always a good idea to do that. And leave the 1/4, x plus 1/2, that's so we get 3/2 x minus sine 2x plus 1/8 sine 4x. Okay, and that is the integral. Okay, let's do another one. So there are a lot of different types that you see. And sort of like another standard type would be the following. You have the integral of, let's just say it is root 25 minus x squared all over x squared dx. And once again, you can check for yourself. A U substitution is not going to work here. Why? Because if you take the derivative of the inside piece, you get times 2x, and that's an x squared. This is a problem. So whenever you have the square root of a square minus another one, this is where you want that x equals, and then we'll go with 5 sine theta. Make a substitution, so what's dx then? Dx equals, well, dx is 5 cosine theta, right? Now, we don't see the cosine theta here, but we know with our trig substitutions that we can probably get it. So let's just go with this. Oh, remember the plus c's? Gotta start to get used to that again. Okay, so let's make our substitution and see what we get. What we end up with, we've got square root of, and we've got this 25 minus what? Well, it's 25 minus 25 x squared, right, is 25 sine squared theta. Then we've got this x squared in the bottom, which is, once again, 25 sine squared theta. And then look at the dx. So dx should be d theta. Okay, so what we can do here, we can just write this in terms of what we have. Dx equals, and we just write 5 cosine theta d theta. Okay, so let's try to simplify this now. So first of all, we can pull out the 25. The square root of 25 is 5, right? 5 times 5 is 25 over 25. Those cancel completely. Okay, so what we're left with in the numerator, we're going to have square root of 1 minus sine squared theta. Denominator, we have sine squared theta. And we still have this cosine theta d theta. So it looks like a lot, except 1 minus sine squared is cosine squared, right? And so you put in cosine squared there, that's just cosine. So cosine times cosine, this reduces to basically cosine squared theta, sine squared theta, d theta, and note that that is, we have to think about this one for a minute. How are we going to handle this? Well, the cosine squared over the sine squared that's cotangent squared. Cotangent squared theta d theta. And it turns out, so you need another trig substitution here. And so, for instance, you know that sine squared plus cosine squared equals 1, right? And so if you want cotangent, how do you get cotangent out of this? You would divide everything by cosine over sine divided by sine, right? Because cosine over sine is cotangent, which is what we just had. So you divide everything by sine, you get 1 plus cotangent squared equals 1 over sine squared is secant squared. No, cosecant squared. Okay, and that's the identity that you have. And so what you can do then, you rewrite this as the following. You rewrite cotangent as the integral of the cosecant squared theta minus 1 d theta. And you may or may not know the cosecant squared, but in effect it is the, how would we say it? It's the negative cotangent of theta. That is the straight integral. Okay. This would just be theta. And then, we have our plus c. Now, this is given to us in terms of x, and we wrote it down in terms of theta. So theta is the sine inverse of, x over 5, right? Because if you have x equals 5 sine theta, and you solve this for theta, it's x over 5 equals sine theta, okay? And put that up here. So we get x over 5 is sine theta. And so you take the inverse to both sides to get the correct answer. And so theta is sine inverse of x over 5. And so it's not the neatest way of writing it. I can show you like another way, because like what's the cotangent of theta? What you want to do here is probably have a right triangle. And so if you have a right triangle, what do we have? We have theta here, and then we need to know what our sides are. Well, look at this. Sine of theta, because its opposite is x over 5. Okay? And so by the Pythagorean theorem, what do we have down here? We have, well, it's 25 minus x squared, right, which you see up there. And so a nicer way to write cotangent, well, what's cotangent? Cotangent is it's not opposite over adjacent, it's adjacent over opposite, so it's in effect 25 minus x squared, square root over x. And then we just said what theta was. Theta is the sine inverse of x over 5. And then you have your plus c. The 25 minus x squared, oh, yeah, for x. Okay, so not easy, right? And so, but let me just summarize sort of in general trig substitutions. So we looked at a lot of, sine squared, cosine squared, even some cosecant squared. And when you have higher powers, you kind of want to reduce down to those, right? These substitutions that we looked at, where you've got sine squared is 1/2, 1 minus cosine 2x. And then the cosine squared is the positive version of that, is huge. Same with the 1 minus cosine x squared, etc. We use that here. The difference with this one is because you have the 25 in the root, and the squared, that's a sign that you actually want to change it to x equals 5 sine theta to sort of cancel out the 25, cancel out the square root, and you just get a standard trig function. So you have to be careful and take care of your thetas and then work with it at the end, okay? I do want to go over one last type, and it could be something like the following. So if you have to integrate, say, let's go with the sine of 2x, then the cosine of 5x dx. Okay, this is a different type. It's not dealing with any powers, but it's dealing with sine and cosine together. And it's a little bit awkward because the 2x and the 5x don't match. Okay, so to do this, you need a different approach, and what you want the following trig identity. Okay, we've got that the sine A cosine B equals 1/2, and then it's sine, and it's A minus B, squeaky marker, and then plus sine A plus B. Okay, and so you can see that this is actually going to lead to a straightforward integral, because when you rewrite it, okay, so the 1/2 can come out, or I didn't give myself room, so I'll put it in, and then, so sine of what? So it's sine of, well, I just subtract it to negative 3x, and then this is going to be, add them up, sine of 7x. And so you end up with something that's pretty straightforward to integrate. Let's go ahead and do it. The 1/2 comes out. And then, so sine of 3x is the negative, okay? It's the negative sine of, 3x. And that's the derivative of integral of negative sine is a positive cosine. So it is the cosine of 3x. Now, there is no sort of times 3 with it, and so what you do is you just divide by 3, okay? So now, right, if you take the derivative, you get the negative sign, the 3's cancel, and similarly with this one, this is just a negative cosine 7x over 7. We have our plus c. So you can see that's another trig type. I think when it comes to doing trig integrals, what you need to do is you just need to look at sort of the type that you're presented with and try to find the appropriate trig substitutions and consider memorizing the ones that you use a lot.